we look at a new method for the same problem of find min max of a quadratic with a quadratic constraint. Here we're going to take advantage of the special formation of this quadratic, that is x squared plus y squared versus xy. So here now from the constraint and the objective function here, you can rewrite it so that it becomes plus xy and minus 2xy, right? That's the difference, 1 plus 1 minus. So the objective function is 3 minus 2xy. In order to find the range of S, we need to find the range of xy. Now here again, we're going to use the relationship between x squared plus y squared and xy. Now imagine if you have a fixed value for x squared plus y squared, in other words, the xy is going to be on a circle, right? Where the constant c here is going to be the radius square, r square, right? So if that is the case, what is the value for xy in this case? So this is another kind of a extreme value problem. Basically is asking for all points on a circle when we'll take the maximum and minimum of the value x times y, right? Of course, one way of doing that is to use a parametric equation for a circle. To answer this question, we're going to use cosine alpha and sine alpha. This is a parametric equation for points on a circle. And then if you say x times y, that becomes c, which is r squared in this case. And then sine alpha, cosine alpha, that's half of sine 2 alpha. Of course, the range of that would be from sine. For sine, it takes value negative 1 to positive 1. So xy is going to be negative c over 2 to positive c over 2. What is c? C here is the value x squared plus y squared. All right. So that is the relationship between the two. So let's recap. So in this case, the maximum value happens when y equal to x, right? Minimum value when y equal relative to s. In other words, in this here, the point CD takes a maximum value of x times y. The point AB, where y equal relative to x, these 2 points takes the value of minimum value of xy. All right. So with that, we can solve the original problem by taking use of this relationship. Okay. So here we go. C, what is C? C is x squared plus y squared. So we have this from earlier reasoning, right? So now let's take the second half of this equality. We're going to rewrite this equality, right? 2xy, multiply by 2 on both sides, it become this, right? So here we're going to take use of the second half of this inequality. From here we know that that's the case. So x squared plus y squared plus equals y equal to 3. So we know that xy is going to be less or equal to 1 in this case. Now, by looking at the other half of the inequality, in other words, by looking at this part, what you can do, we can minus xy on both sides, right? If you minus xy on both sides, you know that xy is greater than negative 3, right? So that's good. So with the given constraint, we have figured out xy's range, right? So xy is in this range. Now earlier we said that the objective function is 3 minus 2xy, and we know xy's range, so we know the s must be in between 1 to 9, which is the same as what we get using other method in earlier videos. Okay. Here, of course, the question is, are those values attainable? What xy will take the value of 1 and 9, right? The answer is yes. Of course, earlier we know that the extreme value of xy happens when either y equal x or y equal negative x, right? So when y equal to x, from the original constraint, we know that all the terms equal to 1. So the objective function here would equal to 1, right? 3 minus 2 equal to 1. What if y equal negative x? Then we got what we got is x squared y squared equals 3, but x times y is opposite sign, is a negative number, right? So the value of that is going to be 9, the maximum value. Okay, so here is the final answer. The minimum value is 1, is achieved when y equal to x. Maximum value is 9, is achieved when y equal negative x. All right. So please check out other videos for other methods. So earlier we have linear transformation, and there's also homogeneous forms by using y equal tx. And of course, there is Lagrange multiplier for constraint optimization problems. So that is another way of solving this problem. And so the total is 4 methods. Okay, please check out all the videos. Please like, share, and subscribe to the channel.